Ready?
Yes, sir.
Good morning. Sorry. Good evening. This is Anil Baliga, the chairman of Mangaluru Indian Concrete Institute. That is, in short, we call it as ICI, Mangaluru Centre. And every month we have been conducting this particular webinar series in collaboration with Qcrete Readymix Concrete Private Limited. And they have been our respected partner in this series, where knowledge is being shared across the engineering fraternity. And today is our this special series, and in fact we have a special person with us, Dr. Ajay N, who is the senior structural engineer, and he'll be enlightening us with his expertise, the recent developments, and the projects what he has been executing for quite a long time. That is almost 17 plus years, almost 17 to 20 years. Really, I'm literally I'm very happy to read out his the biography, and it becomes my privilege to introduce today's speaker and the guest and the resource person, Dr. Ajay N. He has been, as I said, he has been a very practical person, and in the field for almost 17 plus years. He started his career as a various organizations after his Bachelor of Engineering degree in civil, and later he went on with MTech post graduation in pre-stressed concrete, and he also added doctorate to his name under construction technology. And very happy to say that he has been associated with many organizations, and to name few, Scrum Master and ACCI, that is Association of Consulting Civil Engineers, and he's also a member of MIE. And he has been all-rounder, I should say. You name it, he has the abilities of designing such structures, whether it is residential, commercial, industrial, or infrastructure, anything you name it, and he has it. And he is also very tech savvy structural engineer, so that he is simplifying his job by using many softwares like ETAPS, StatPro, Risa, Midas, AutoCAD, anyway, part and parcel, and Revit, and other than that, many other applications. And in his professional career, he started his immediately after his engineering or the graduation. He joined Geodesic Techniqueps Private Limited as a trainee engineer, where he was dealing with buildings and infra projects. And later he joined one of the tycoon, I should say, BBR India Limited, which is a specialist in post-tensioning and pre-tensioning, and it's a MNC, where he dealt with buildings, infra projects, and major the bridges. And later at Rendrack Private Limited, he went on with this designings of buildings, infra projects, and structural evaluation works. And later at Rasta, it is a Center for Road Technology, where he was more concentrating on infra projects and entity works. And till date, he's working as a senior structural engineer at Advaita Consultants, Bangalore, wherein he is dealing with almost all types of structures, buildings, that is infra projects, and structural evaluation work. In fact, as I was going through his biodata, literally I had a tough time deciding what to say and what not. With this very brief introduction, sir, I would like to invite you to this August gathering and this forum, and request you to kindly enlighten all of us. Thank you so much, sir. Over to you, Dr. Ajay.
Yes, sir. Thank you, sir, for a brief introduction about myself. So, I very much thanks to, first of all, thanks to ICI Mangaluru Centre, as well as Sri Anil Badiga, sir, Chairman of ICI Centre Mangalore, and also thank to Sri Eknath, sir, Secretary, ICICI Mangalore Chapter, and I would like to also thanks to Sri Suraj as a Treasurer for the Mangalore Centre, and I thank to Qcrete, our Director, PR Kaushik, sir, and Shile Fernandez, sir, as a Managing Director. So, because they are providing me opportunity to deliver my lecture on my topic, rheological properties of SCC, and always I would like to thank my professor, Dr. S. Girish, BMSc College of Engineering, for his continuous guidance, support, and everything. So, I'll also welcome to all the industries people, academicians, researchers, students, everyone for my lecture on rheology of fresh SCC. So this is my presentation outline. So I will start with workability of concrete and measuring through slump test, rheology, why it is required rheology as for today's concrete, and how to rheology of fluid is relevant for our fresh concrete conditions, and how will we measure these rheological properties. So this is outline of my presentation, today's presentation. So I think I hope everyone in this presentation audience, they are all well known about the concrete and well known about the properties, everything. So I will give very overview of my lecturing on 1 hour, because it will take almost 2 to 3 hours for in detail presentations. So I will summarize all these things, and I will give necessity of rheological studies as for today's concrete. So this is my main agenda to deliver my lecture. So we know that workability. So what is mean workability of concrete? Because the concrete, when we say concrete, is a heterogeneous material, because it will show, it will exhibit when we mix the concrete and when we start placing or finishing the concrete, and in the compaction of the concrete, that concrete means it's a combination of ingredients: cement, aggregates, and water. These are the basic 4 ingredients what we are using very traditionally and very conventional methods. And when we mix the concrete, the aggregate part is suspended on the mortar part, and mortar is suspending on the cement, cement suspending on the water. So this is completely acting like a complex fluid. But as we saw that when we as a industrialist, as a engineer, structural engineers, we are more concentrating on strength part rather than our workability part, because we are very keen about my strength, because we are very we required M20 grade, M25 grade, and today we are going with M80, M120, like that. We are very concentrated on our strength part, and also today also we are moving with durability studies, more on concentrated on sustainability materials. So we are very I can say we are not very much advanced in testing of the fresh properties, because the concrete is when we look into as a fresh condition, we are checking that basically workability means what the definition says. When we mix the concrete very easily, it should be very easily had to mix. Compaction, placing, and finishing should be very smooth, and it should be maintain the homogeneity till the functioning from mixing to transportation, finishing, compaction, everything. And it should not get segregated, it should not get bleeding, and it should be very compatible mixes, and it should be finishable. So all these things we call as the workable concrete. So how will you assess this workable? On what basis you have to assess the workable means that is only through the measurements. So based on the measurement only we can come to know that the workability is there or not. So how will you measure? Generally speaking, the workable means from our mind or any engineer says that workability is nothing but we start with the slump test. This is the very fundamental. Any engineers they says we can conduct a slump test to check the slump of concrete. And in the laboratory, when go for our engineering terms, we check with the compaction factor, VB factor, K-ball, and floatable test. These are the few tests what we have done in as per IS code recommendations for the fresh condition assessment. But ACI 238 code, they have listed out about 40 testers has there to conduct the test to assess the workability of the mixes. So among these 40 tests, but still today also we are start with the slump test, because the slump test has its own merits and demerits. You can say demerits or limitations. So what about the merits? Means it has its own 100 years of history of the slump test, irrespective of the concrete, whether you're doing a conventional concrete, high strength concrete, high performance concrete, SCC, and any concrete you can start with 3V. And when we design the mixers, we are choosing the slump of the values based on the conditions. IS 10262 2019, we are designing the concrete mixers based on the slump values, and we are back reference to our IS 456. So based on application, so where we apply for the road, bridges, building, where we are applying, based on that we are choosing our slump value, and we are choosing the compaction factors. So that code book table number 3456 has clearly says that table number 3 that clearly says that the slump value based on applications. So that value we had to choose for our mix design, and we are calculating all the ingredients required for the grade of concrete. So like that, this slump has its own merits, and it is very simple test, and it is easily handled, and it not require any additional electricity, anything, and is more relevant for our field application, where when we place the concrete in the formwork, in the slab or beam, so when we lift up, the same thing we are following in the field also. We have placed the concrete gets spread out. So this spread out, the same simulation we are making in the slump also. We are uplift the slump cone, the concrete gets spread out, and in the field we are using the vibration machine, and here we are making a tampering because we have to make a compaction. So the simulation, based on this simulation, they have developed a slump test, and this slump cone is also called as the Abraham cone, because the Abraham in 1924 he has developed this slump cone, and he has tried with so many different shape, square, rectangle, anything, but he come to fine tune this and make us a spectrum of the cone to make the simple work, and this not require any analysis. And here we are measuring the distance, how many distance we have traveled concrete, that is 10 mm, 5 mm, like that we are measuring the distance. So this is the main advantage as well as merit of this slump test. And other part was what will happen, see that concrete has evaluated in 2024, as I said, the Abraham has started this concrete designs, everything in 1924. At that time, the building was low-rise building, mid-rise building, what they have constructed that time. And that time, the constitute of the concrete also, the basic fundamentals, cement, aggregates, and water. As on, application is evaluated, and requirement has get evaluated, the application also get evaluated. So we are try with many admixture, we are making, because we have to make cut down the cement content as they make us more optimization. Then we introduce the mineral mixtures as a filler like a fly ash, EGBS, resin cash, any filler material we are adding to customize and we optimize the cement content. So we are introducing the high strength concrete for to get the high for because we for the removal of the formwork and get the high strength, and later on get into high performance concrete and fiber reinforced concrete and evaluated with the self compacted concrete, GPC, and nowadays we are going ultra high performance concrete. Like that, we are the concrete has get evaluated, that completely get evaluation from 1924 to till today. We are getting very advanced and special concrete, as I said, and we are introducing more and more filler materials. As of in 24 or in maybe in 10 years, 15 years back, what we are using the admixtures, as of today's admixture, and especially that that time we are using a river sand. Now we are using the M sands, and we are also using a partially replaced with the CND waste, and everything we are adding the ingredient for a concrete, and we are making more optimize the concrete mixers to get the strength and durability. That is the main agenda of the any engineers. We want to get the strength as well as durability. But what about the test part? That is fresh property, because we are what we can see the fresh properties we are not very much testing in advancedly, especially for any concrete, because till today we can use the slump test to measure the prediction of the workability. So in 1994, the Popovics, as a researcher, he has stated that he has published one paper that called as slump test is useless, or it is, that clearly gives some evidence of the limitation of the slump test. So why it is limitations? Because based on this paper, we have conducted some of the experiment in our laboratory, especially in the BMS College of Engineering during my research work. So first question, the slump test is not suitable for low workability mix, because the IS 456 clearly says that 0 to 25 mm for road application. So based on this, we had started with low workability mixers with a very conventional method, very conventional, only have using 4 ingredients here. We are not introducing any additional admixtures. The mixers, we can see here that cement is 300, water is 115. The slump shows again 0, because very harsh mix. When we adding the extra water, 130, 145, but as a scientific manner, when we introduce the water, automatically it get reduce some frictional force. So automatically when get frictional force get reduces, between frictional force between particles or aggregate get reduces, automatically slump values getting down. But in this case, what will happen? That lower workability mix is showing still 0. So it clearly says that slump test is failure to give the differentiation between the mixers among the mixers, because we have different 3 mixers, but slump value is same, 0 value. Again, another experiment what we have done with a different mixers. These are all experiments we have conducted in 2018. So here we are chooses 300 mm cement, 160 as a liter water without any admixtures. I am getting 20 mm slump. Again, I am using 450, the maximum cement content and minimum cement content as per the code of provisions. So here also I am getting 20 mm slump. So here also I cannot differentiate the mixers. Which mixers is better? As a strength point of view, yes, 450 is maximum. So I cannot take as a, because the strength point of view is acceptable, but as the economical point of view is not acceptable, because almost 450 we can get a shrinkage cracks. So I cannot accept. But here the value, here this thing was, we cannot differentiate the mixers. But both mixes have some coincidence, but the values are same. And same we apply for the SCC also. Here for SCC we have different powder content, water content, and SP also more or less 0.05 and 0.1 dosage variation will be there. But the slump flow shows the same thing. And more or less both give the same almost distribution was particle distribution, aggregate suspenders is almost same. Both will be more cohesive mix, but the values are almost same, 700 mm. So the slump flow or slump test is not differentiate the mixes, because when we alter the cement, water, it should give some different values, but it's not giving different values. But fundamentally, as because that Abraham law, what we say is the universal law, water cement ratio versus strength. When we increase the water cement ratio, the strength get reduces. So when we increase the water cement ratio, automatically that slump also get reduces, because the frictional force between the aggregate to aggregate, the binder material, what we are using, the cement and fine aggregate, it is acting as a binder material and a coating material for the aggregate. It acting as a lubricant mainly. That lubricant, when you increase the water content or introducing any high range water reducer, automatically the slump value get reduces. So, but in this case, what will happen? Not give the differentiate. We cannot make a differentiate. This is another case. First case, we have a different mixes, but showing the same value, slump value. Here we have different mixes again, it also showing the same slump value. And I am trying to do the same repeatability. Continuously, I am doing the same repeatability of the mixes. I am getting different values. First time I am getting a 20 mm. I'll take out, and again I have to firstly have conducted. I am getting 35 mm. Again I have conducted. It will give 40 mm. Like on, it will give a different values. It not give a repeatability of the values. And this may be a depends upon how we operate. That is also come to picture. And there is no repeatability in the slump test, and we cannot differentiate the mixes. And the same slump, sometimes without any tapping, it's showing zero slump. When we make a tapping, because of the compaction, voids get erupted, it so come down to 50 to 75 mm slump. So this is the how limitations what we can see in the slump test mainly. It not only for the low workability, it also for the flowable concrete and high flowable concrete like SCC. In general sense, we can say that the slump is more subjective assessment. So in some slump, as I said, what will happen in the slump is more relevant for the formwork placement of the concrete and spread the concrete on the formwork, tapping. The same thing we are simulating with the slump also, but here not taking account of the pumping effect, that is dynamic effect. So, and also when we have introduce a more powder, not giving an indication of the more powder, or when we introduce a SP or supervisor, not giving indication here, it clearly give, and it is not giving a proper differentiation between which mix is better. How will we choose? Because at practically what will happen, we require 125 mm slump. We order for 125 mm slump for RMC's companies. So they will do based on the traveling time and slump loss. They will do 175, then they'll reduce to 145. Like that, they come to 125 at the site. Then once they pump the concrete at 10 story, 9 stories, then we are not checking with the slump at place of displacement of the concrete. We are assumed that the same slump. But at end result, what will happen when get the attain of the strength? There may be a number of factors will be there to achieve the strength, because the compaction, water cement ratio, finishability, placing, everything will be there. But the fresh property is also very much important for us to take care, because vibration effect, everything has to be taken care when doing the concreting part, but that is not indicated in the slump test. And here, sometime what will happen, we taking as a collapse. When we get concrete get collapse, we not accept the concrete, and it gets shear, we are not acceptable for the mix for the placement. But that will give some indication, but we are not going to check why is changing the collapse, why it is giving the shear, why it is giving a true slump, on what basis it will give true slump. So it is a completely a science approach method. So we should know science, that is we call as the particle distribution method or particle density methods we have to be followed. So because the aggregate and coating material like your cement and binder material heavy coating with the aggregates, it acting as a lubricant. So when we have a horse mixture, the horse mix has more frictional force between the aggregate to aggregate. Therefore, we're getting very harsh mixes with a zero slumps. So when we introduce a more water reducers, automatically it acting as a lubricant, it will get down the slump values. So in general, we can say slump test is not much relevant for as of today's advanced concrete like SCC, GPC, FRC, light aggregate concrete. It is more or less we should, and the main concern was this is not a material science approach method. It is like a subjective matter, and we can take as a quantitative measurement scales like 10 mm, 12 mm, and here clearly we are measuring the distance. It is a based on the single point parameters. We call as the 1 point parameters or single point parameters. We are judging the concrete using a 1 parameter like a distance. It's like the same sense. We also have some other tests. Similarly, we have VB, compaction, flow table test. All these things based on the application point of view, right? Because the compaction we are not generally doing in the field. All these tests we are conducted in the laboratory. This all because, and here the compaction is based on the height of the concrete. So what we that we will get the segregation or not, we are checking the segregation or the cohesive of the mix. And VB, we are checking the shape, how much time to take the shape from conical to circle. And here we are measuring the workability with respect to time. And in the flow table, we are respect to the distance again. Like that, all these methods, what we say is slump, VB, compaction, cable, what we have almost ACI code says 40 tests. These are all we call as empirical, because here we are measuring the workability mainly basis either by time or distance. And the same also we can came to know that it is not now, it is in 2028, 36 and 40 itself that researchers they have give the sublimitation of these empirical tests. So the power, the TC Power has written the one of the best books in the concrete technology, because most of the time we are going with the Amin and Neville and Shetty book. So when read this power book, when we come to know that the concrete has n number of partial differentiation equations, so very get surprised. So the concrete also have so many mathematical equations. So they have written a very good book with a TC Power. And in 1983, the Tata Shell, he has argued again the slump using is a single point test. It is we want to look into some better test for the concrete. So on this basis, what will be our answer? Because as the researchers, so many researchers has proved that the slump test limitations and other test limitations, they already proved that. And also based on that, we are also conducting some of the tests in our laboratory to get the confirmation for this, whether the slump is they have limitations or what limitations. Yes, that clearly says that the slump mainly is a single point test and is empirical. There is no any scientific behind this slump, because we are may place the concrete. For SCC also we have using a slump flow T500, and we have V funnel, J-ring, L box, U box. Everything we taken as a is empirical. It's not like any, we did not be behind any scientific approaches there. But when we describe the concrete, we should describe in the two parameters. It is must and should for the nowadays advanced concrete, because we can describe with two properties. It will give a better better mixes, concrete mixes. So we can differentiate the mixes among the which mix is better or which mix we can take out for the placement. And this fresh property assessment and fresh properties we can, when you make a better assessment or better test, of course that will clearly give the better strength and better longer durability for any material, any structures. So what will be our answer for this? When you take all this previous researchers, everything, so some tests, yes, of course we have limitations, because the lower capability mix also we have different mixers saying some same value, and for SCC also they are saying same values. So for advanced concrete and special concrete and conventional concrete, we cannot describing the concrete difference. We cannot differentiate the mixers. So why we require differentiation means to make the optimization of the mixers and cost. You have to make a cost cut-downs. So what will be the more relevant as per today's means? The answer was rheological studies. So why it is rheological studies much important as of today's concrete means, because the concrete has a say that aggregate, and aggregate is suspending on the mortar is suspending on the cement again suspending on the water. So this is very complex behavior. For example, if you take a self-compacting concrete, if you add just 0.1 dosage, it will behave very differently. And when you add extra water, it will behave differently. We cannot get the same mixes. So again, it will very, you can see, we cannot give that proper, what will happen, we cannot give that answers for that, those things. So for this condition, we required a more relevant and scientific approach is better rather than the empirical. So therefore, we required more authentic and scientific approach method, that is we call as rheological studies. So rheology means, it is a Greek word. It is everything is in flow, and logy means study. We are studying the flow properties, and this rheology is general word and is a very general word, and it is used for all the different materials and how it relevant for our concrete. So for example, we taken in rheological studies, we know that there are two type of fluids. One is Newtonian fluid, other is non-Newtonian fluids. When come to Newtonian fluids, the water is the best example for Newtonian, because the shear rate and shear stress both will be proportionate here, and we are not getting, we can easily calculate the viscosity. Using this equation, we can easily calculate the viscosity. And the same thing for non-Newtonian, what will happen? We have again classified with the time dependent and time independent. So these are the very complex fluids. For example, like a self-cleaning glass and gels, medicines, and any cream, toothpaste, everything we can take as a complex fluid, because some fluids have more independent, time independent, and again we are categorized as a shear thickening, shear thinning, and Bingham viscoplastic or Bingham plastic, and also we can take as a time dependent isotropy effect and rheopathic effect. So in this, among these, because again is a different domain, rheology of complex fluids. So I'm not going in deep on this as completely on these topics. So among these fluids, we can take as a concrete is more relevant as a Bingham fluid. Why? Because the Bingham is a researcher, is a physics chemist. He has developed the model, mathematical model, and it will give all these different fluid. We want to calculate the viscosity. That is the main thing. Therefore, we want to check using the rheological study, we can predict the complex fluid behavior. So based on these equations and based on the, see that in 1984 and 83, they have started these studies on the concrete technology. Why rheologists matter is done by Francis D. Lerdo. He is giving a clear picture in his paper, and in 1983, Tata Shell has bring that rheology is must and should for the concrete, because, as I said, the slump and any method is, as of today, is only give the a single point. We cannot describe the concrete, we cannot differentiate the concrete, because when we take as a pumping effect and vibration effect, everything we should be considered in our design, and in the fresh property also we have to be checked. So that has to be taken care in the fresh property itself. Therefore, we clearly says that the fresh condition of concrete is completely acting as a complex fluid, and it behaves a complex behavior. As I said, the aggregate is very heavily aggregated, density aggregated. It is viscous with the cement paste, and cement paste again concentrated with the water. So it will show very complex behavior. When we pump the concrete, see, the rheology of fresh properties means the rheology is nothing but that we have to study the fresh properties of concrete, the flow of the concrete. When we pump the concrete from ground to 10th floor, 4th floor, 5th floor, it will start from, it have n number of, have 2 bends, 3 bends will be there. So the concrete has to go through the bends without any changes in the fresh properties. But this type of the test we are not conducting in our laboratory, because we are checking with the slump test, and in slump we are not making all this into picture. So we just give a slump, and based on slump we are designing the mixes, and we are give the site. But in practical, what will happen when we pump the concrete for 10 story, it will have 2 to 3 bends for the pumping that concrete, and for the high pressure. All these effect has to be considered and has to be assessment in the fresh condition. Therefore, it will make, and also once of the placement of the concrete also very much essential. What will the slump during the at the placement of the concrete? So this is, we can easily calculate, or we can easily determine shear stress and shear rate for these type of shear stress and shear rate. That is, we call as the rheological properties of the concrete. And this study has started in 1930. He has started with first attempt, and follow with the 1941 and 71, 73, 70, again 83. At Tata Shell and Banfield, he has clearly come up with the concrete in fresh condition. It acting as a very complex non-Newtonian fluid, and they have classified the concrete test class 1, class 2, and class 3. The class 1 was, again, there's the qualitative, that is like whether the concrete is workable or flowable. Make our by visual observation, we can give the classification. And class 2 was they classified as a slump, compaction, VB, all these classes are empirical. And class 3, they have come through that rheological studies. So here we are discussing about more on to viscosity as well as the heat stress value. So these are the things we have discussed in the rheological studies, and it is more is all actually required for the and this study continuously they have done research work on this rheological studies, and in 2008 the ACA code has come up, and he has clearly recommended that in 2008 itself they have recommended in they have for better understanding and measuring the workability only through the rheological techniques. And because this code book clearly says that we can describe the concrete in a scientific manner, because as I told, today's concrete introducing a n number of we are using a create tertiary blending, and introducing a more number of chemicals and filler material, and we are replacing the CND waste, and we are replacing with slags. Everything we are making a more and more advanced, and we are introducing more and more admixtures. So for this type of the concrete, we require a scientific description to check the fresh properties, and we also get the workability. So for these conditions, we require the better understanding concrete, we require rheology. So how will you measure rheology? So we have to measure the torque as well as measure the rotations, and these torque and rotation we have to fit in with the mathematical models. They are developed by Gaussian, Asher Berkeley, Bingham, power, that is shear thinning, thickening. These are the models, mathematical models. So these values has to be given here, have to be made to that mathematical models. And among these equations, the Bingham equation is more fitted for the concrete in the fresh condition, because we are measuring this torque and rotation using the rheometers. So rheometer is a device where we are measuring the shear stress as well as shear rate and get the output values and fit in with the mathematical models. And again, rheometers, we have two type of rheometers. One is extensional rheometers and shear rheometers. For concrete, we are using capillary rheometers, rotational rheometers, and more of the case, we are using rotational rheometers. And in this, we have different
Kanishk? Hello, Kanish? Hello, Kanish?
Yes, we have lost the connection. I'll check.
Kanish?
Sir, I'm checking, sir.
Yeah. If you have Ajay sir's contact number,
You can read that, sir. He has lost his connection. He will be rejoining soon.
which is
Sorry for that connection issue. Sorry. Yeah, we are into the theoretical model. So from rheometers, we are get the values for shear stress and shear rate, and fitting with the Bingham equations. So the Bingham equation is similar for concrete, means that any concrete has some initiate force will be there. That force we call the yield stress, because aggregate to aggregate we have friction force. And for example, any SCC mixers we can take, when we fill up the slump and to start uplifting the forces, that we call as the main minimum yield stress. That is force we call as yield stress. And the time traveling from formwork fill up is called as the minimum time. We can call as a viscosity. So these both parameters we can fit in the Bingham equation. Therefore, many researchers has clearly proved that this equation and this flow curve is more fitted for the fresh properties concrete. So this is used for all the rheological properties of concrete using this yield stress and viscosity. And the research clearly says that using this Bingham equation, we can describe the concrete with a two parameters. One is yield stress and viscosity. Here we can see that they have two. This is the research work by Ferraris in 1982, and it clearly says that we have different mixers. We can differentiate in here. One mix have same yield stress with different viscosity, and another mix was a different viscosity, the same viscosity but different yield stress. So this differentiation we can make using these Bingham as well as rheological parameters. But in case of slump, we cannot differentiate the mixes. So therefore, to differentiate the mixes and to get the better understanding of the concrete in fresh condition, we require the rheological studies. Is clearly proves, especially today's concrete. Of course, it required more and more properties. And among these, we have using rheometers, as I said, and rheometers. What will happen in rheometers? We are using for to check the dynamic conditions, and in the and most of the rheometers have developed for the lab conditions, not for the field application. Very portable. Few we have what we have ICR and some of the SCC, DP. Like this, we have some of the rheometers available in the market, and it is again it is only particular for the particular concrete, and it is we cannot do all the concrete, means conventional, high performance, global, high flowable. We cannot do all the concrete in one particular rheometers. Suppose we want to do that, means we have to change the blades and we have to change the systems. So like that, we have some limitations in the rheometers. And in 1998, the Ferraris, they have conducted some tests with the same mix with different rheometers, and that results clearly says that the same concrete mix shows a different values in different rheometers. And all these rheometers is only for the flowable and high flowable concrete, not for the low workability mixes. Therefore, in 1937, the Hellermet and Turner, they have studied the shear strength of a concrete using dead shear box. The same system as adapted and they carried out in 2007 by our Professor Dr. Girish and Professor Dr. Rangnath, R.V. Rangnath. They have carried out the same system adapted to check the rheological properties using the small shear box, what using the soil properties, shear strength, and they have conducted some test and get good results. Based on that, in 2009, Professor Girish as well as Professor Rangnath sir, they have designed and developed a new instrument called concrete shear box. This is the concrete shear box that developed in BMSC College of Engineering. So it is completely sensor-based system, and here the principle was same where we using for shear box, the small box, soil, the same methodology adapted here, and but the size of the cube is 150 by 150 size as per the cube standard, and we have applied with the normal stress applied to regulators, and we have a gearbox, and we have applied normal stresses to the prismatic accelerators, and everything is completely sensor based system, and we are measuring all these things through the sensors, and this is developed in 2009, and later on we come to know we had checked the feasibility of this instrument. That is the main aim for my PhD topic, and here we can apply the normal stress up to 1 MPa and maximum shear load up to 550 kN we can apply here. And in my research work, we are conducted all type of the concrete, like conventional concrete, flow over concrete, and high flow over concrete like SCC. All type of concrete we are conducted in using to check the feasibility of the shear box. And for M1 to M9, it is like a lower table mixers, and M13 to M21 is a flowable mixers. So all the type of concrete we getting the both values, and the difference between shear box and rheometer was the principle, where the rheometer is working on the dynamic principle and shear box working on the static principle. And here we are checking the rheological properties after the placement of the concrete and the formwork, and where the rheometer is working on when they pump the concrete, the pumping effect they are considering, but we are checking that when concrete get rest after the pumping effect, vibration, everything get done and settle down on the formwork. So we are checking actual more relevant for the field condition. We are checking the heel stress and viscosity. So that is because the rheometer what will happen, they are checking beginning after the pumping what will happen. They are checking all these things, but we are checking more relevant for the field application point of view. And the shear box giving all the properties, you can see that mixes difference, because M1 to M9 the mix is showing 0 slump, but using these two parameters we can really differentiate the mixes. And the same thing we apply for the SCC mixers also. We have conducted a slump flow, T500, L box, all the things. So in SCC also what will happen, we had to assign, because SCC means we have to fill with three flowing ability, filling ability, and segregation resistance. So we had to conduct 3 to 4 tests to get the confirmation. But when we using these rheological properties, we can easily describe the mixes. And other main, so you can see M22 to M48, we have conducted almost 20 to 25 mixers, different mixers, and every mixers we get the heel stress. And here, other main point from our research is that when we heel stress, because that minimum is decreases, because the volume of paste means cement, water, and filler material, we call it the volume of paste, or we can also call it the powder, cement plus filler material. When this automatically the conversion gets reduces, it behaves the same manner. And also with the of paste, the heat VP, the viscosity get my clear of the case for they're giving that which occur like this, but in my studies clears that up to 800 mm is 0 to up to 800 mm can use. So above after 800 you cannot go with the Bingham, so you prepare more on modified Bingham equation or claim model. So this is the and box is more feasible to get. And also we have conducted the SCC, also we have with the GPC mixers, FRC mixers, provide aggregate property shear box. So that shear box is clearly that we can use shear box, get all physical properties and meters, and this is the SCC. We have to get the users and whatever we get because very hot within so get in the single instrument we can get all type of mixes rheological properties. And what relevance of this? So, to understand that results is see the results in the slump T500 we cannot differentiate the mixes. For example, we have 300 cement and 0.5 is AC, this thing, we cannot differentiate the mixes. But using the rheological studies, sorry for it. So the main was that rheology study is very much important as for today's concrete. It is very much, and the shear box is giving more authentic results for the practical application. And the slump, they have their own limitations, and we cannot. The slump has their own limitation, and they're all empirical methods. And also in our research, we are conducted some mixed designs based on rheological properties. Maybe in the upcoming years, we had to publish some of the papers on using these rheological properties. And most of the, other than India, most of the other countries, they are following these rheological studies based on ACA code. They are conducting all the rheological properties to make better quality of mixes, reduction in cost. So reduction is we get very controlled mixes, quality mixes to for better strength and durability. And these of the publications, and one of the major work, ACI Material Journal has accepted our concept like the shear box, what we getting the results, everything they are accepted, and also other journals called rehabilitation journals, ICJ, Indian Concrete journals, everything they have accepted what we are that new instrument, what we developed in BMS college that accepted. So these are some of the journal paper what we published using this shear box. I would like thanks to ICA once again, thanks to ICA Center Mangalore and Qcrete, Kaushik sir, again director, and also thanks to for all the audience for their patience, and sorry for in between some connections issues. So thanks one and all.
Dr. Ajay, I think it was a very wonderful and enlightening topic, and we have seen concrete as a very versatile, but today you have added one new dimension to it, and we know how exactly now concrete will,
Yes,
function. Thank you so much.
thank you, sir. Thank you once again.
We never thought so much of chemistry is involved. We have seen only from the outside. Yeah.
Yes, sir.
Wonderful, wonderful. Thank you so much.
Thank you, sir.
And dear Kanishk, are you online? Kanishk? Kanishk or Santosh? Hello? Kanishk? Kanishk?
Yes, sir.
Kanishk, any questions you have received?
I'll check, sir. Nandakumar?
Just it's muted for all participants, or you are switching it on now? So
No,
that they can
chat
directly-
box is open. You can anyone can put their question in chat box.
Okay. How Dr. Ajay can access that questions?
I will give you.
Yeah.
Ajay can directly see the questions, or else I'll shoot the question for Ajay sir.
Yeah,
Yeah.
that's better. No? Yes. I request the participants, if at all you have clarifications or queries, kindly type it in the chat box, and Dr. Ajay can throw light on it. Thank you,
Sure,
sir.
sir. Yeah, yeah.
Sir, can I ask a question, please? Hello.
Yes,
Yes, sir.
Mr.
Yes,
Please
sir.
go ahead.
Yeah. Thank you, sir. Sir, I am Sunit Gupta and I am calling from Delhi.
Yes, sir.
And,
Good evening, sir.
thank
Yeah.
you so very much for your nice presentation.
Thank you, sir.
And
Thank you, sir.
I think the concrete has to be, as rightly Anil sir has said, that it has to be looked into a different perspective now.
Yes, sir. Definitely,
From
sir.
rheology point of view, rather than that old 100 years old slump cone perspective. So that's right.
Yes, sir.
So, sir, one is my statement is that yes, in this self-compacting, the properties of fly ash does play a big role. I have seen that.
Yes, sir.
And although people are not looking into those properties of fly ash because they don't consider fly ash as a building material, number one. They take
Yes,
it
sir.
as just as a waste, as it is generally said upon till date. But
Yes,
its
sir.
properties very much decides the quality of your SCC, its rheology, as well as its all other up to strength, whatever properties you want to see.
Yes, sir. Yes, sir. Yeah.
So that was my one statement. Now, I just want to know, sir, the difference between this flow table of both types, where to use. Like one is by 15 times tapping, and other
Okay.
is by taking the measuring the T50 and all those like we do in self-compacting.
Yes, sir.
Where these two tables to be used, how should we differentiate where it's to be used?
Yes, sir. Sir, the flow table mainly meant for the flowable concrete. As per the ACI, clearly says that
That's right.
above 200 mm slump, we call as the flowable concrete, and
Yes, sir.
200 to 550 mm, what we call as the flowable concrete. And now we are calling as a spot dynamic concrete. For those conditions, we want to use this flow table test. And this T500, especially we meant for SCC only, because we want to check the viscosity of the concrete.
No,
So-
that is right. I agree, sir. But where these two has to be used, in which all cases this flow table and that flow table is to be used?
For SGC, smart dynamic concrete, we have to use for the flow table, and for SCC, we have to use for the T500, sir. And the T500 also we can use for SGC, but SCC, when we say any mix cause SCC means we have to check all the filling, passing, and segregation
Yes, sir.
resistance.
Yes, sir. But
Yeah.
for SCC, we cannot use that 15 times tapping that table. In which
Because
we
with
tap,
SCC
in which we tap 15 times, the table is dropped 15 times and then,
that is for the because the SCC, because we not introduce any vibration there. So
no,
the-
SCC we cannot use. Then where
Yeah.
we should use that table, sir? In
which one?
which we drop the table 15 times, and the
That is
slump
for the
cone is
SCC,
less
sir.
small. And
That
the
is for
slump cone
200 mm, sir. 200 mm slump.
Okay.
200 to 300 mm slump. Yeah, that's
Okay,
fine.
okay. Thank you, sir.
Yeah, thank you, sir.
Thank you so very much. Thanks so much,
Thank
sir.
you, sir.
Thanks so much. Thanks so much.
There was an query from Karthik Pandey.
Yes, sir.
How about testing printable concrete in a shear box? Is that applicable?
Printable concrete. Yes, sir. It's like a mortar. So it is like a, yes, actually in shear box also we had done some testing on mortar also. We can do, and for a mortar, we suggested for the small shear box, what we use for the soil property, the same shear box also we can use for the check the mortar, because the particle size, everything is get reduces. So we also try with some of the, actually speaking, that some concrete also we tested in the small shear box with a small size of aggregates, but that again the scale factor, everything has to be considered. So for printable concrete, yes, we can go with 3 small shear box, great shear box.
Super. Thank you. Thank you.
Yeah.
One more query we have from Ravindra Babu Ganjam.
Yes, sir.
For self-compactable concrete, is vibrator necessary? If not, why?
It's not necessary, sir, because
That's a basic question. Yeah.
yes, sir. But because SCC means fundamental was the that has to be fulfilled forward without any additional forces to fulfill the reinforcement, and because that main problem with Okamura professor SCC, because of the labor issues that kind in Japan. So the compaction issues, everything has to be controlled in SCC. Therefore, we are not introducing any vibration in SCC, basically.
And
Yes, sir. One more question from anonymous, sir, in question box. Recently, when we made a very high-grade concrete trial, it became
Yeah.
more sticky, cohesive, and became like a Newtonian fluid. After adding admixture, is there any other way to make it more workable without increasing the water cement ratio?
Okay. Actually, what is, sir, actually, we are into one part of the rheology studies. Actually, another part will be there. It is called as the thixotrophy effect. This is again one of the one of the research area where we have to be looking to thixotrophy effect. Especially for SCC, we need to has to be studied this thixotrophy effect, because the delay of the concrete, slump retention, everything we depending upon thixotrophy effect. So maybe for his query, they have to be looking to thixotrophy studies. And for those conditions, the Bingham equation is not fitting for the conditions. So they want to use some other mathematical models they have to develop to get the how it will behave. And in our research, we have developed some new instrument to check the thixotrophy, but it is still in research only. So we want to check the thixotrophy of the SCC also. We are, myself and my professor, Dr. Girish, we are working on this area, especially on to check the thixotrophy. So maybe upcoming days, we get the some answer for these queries.
Thank you, sir.
Yes, and one more thing. In fact, one Mr. Pinhon Lang Sushiang,
Yes, sir.
he has sent a text about can you give a presentation on SCC only? Actually, when you
Yes.
started your presentation, it was
Yes.
inside me that I should ask you in the days to come, probably just by going through your presentation
Okay, sir.
with the flow, I was wondering, actually, you have done a lot of work in the self-compacting concrete and the new trends in the concrete. I think in the days to come, whenever you are having some free time, I think we all, it's like a public demand. We need
Actually,
once again on this
yes,
subject.
sir. No, actually speaking, sir, apart from myself, I have more, my professor, Dr. Girish, he has done almost 30 plus experience in SCC. And
Wow.
he has done a lot of work on this area. So maybe I will check with my professor if he is okay. So I will request him to take a delivery, because he has done a lot of work on SCC. With all the type of, he has actually developed the mix design, volume paste method, and he has developed this concrete shear box. So maybe he is more authentic and he is giving more inside value in the SCC, hopefully. So if
Sure.
you, I will just check with sir also. So when we are available, so I will just let you with the Kaushik sir. So maybe
Yeah.
in next upcoming days. So he is a better person for SCC.
Excellent. Yeah, and one more thing is in the present trend, as the concrete industry has almost switched over to PC based admixtures.
Yes, sir.
Literally every concrete batch of concrete manufactured is almost like a SCC only. Well, like yeah, there are some exceptions, but otherwise more or less now most of the concrete being supplied performs very close to SCC. May not be
Yes, sir.
exact SCC, but very close to. Means
Close to
the change has taken place. Very good development, and with this, I on behalf of ICI Mangaluru Centre and
Yes,
Qcrete Readymix India Private Limited, would love to thank personally as well as the entire forum on behalf of our participants. Would love to thank Dr. Ajay for a
Yes.
wonderful session on the rheological studies what he has done, and really today, at least with me, a new chapter I've gone through.
Okay, sir.
Which we never thought it will be something like this. So thank you, Dr. Ajay, for
Thank you,
your precious time and the ease at which you are explaining with your beautiful presentation and very simple presentation,
Yes.
which actually will catch the the
Main
eyesight.
highlights.
Yeah, stuck to the screen. It will not allow you to go anywhere. Wonderful. Thank you so much.
Yes, sir.
And at the same time, I would like to thank each and every participant in this webinar. Whoever definitely you are walking out with some new information inside you, and would love to thank the members of Mangaluru ICA Center as well as the faculty members and the technical department of Qcrete for all the assistance for this particular webinar and the Zoom call. And with this, we'll close this session. Once again, thank you one and all. Thank you so much.
Thank you,
Good
sir.
night.
And once again, thanks to all that ICI Mangaluru chapter center and Kaushik sir and Qcrete and all audience for his patience. Maybe get delayed for some connections, and thank you all the back end support, everyone. So thank you, sir. Thank you one and all.
Yes. Thank you so much. Thank you.
Thank you, sir.